Okay, I am going to assume we are live. Hello. If we are, everyone, we are going to wait until 2:03 just to give people time to pop in from the variety of different places that we have set this up so that people can learn and then in turn ask questions. So give us 2 minutes and then we will start off with our VectorDB session. So 2 minutes, 2-minute warning. And while you're waiting, tell your friends. Good times ahead.
Just really shout it from the rooftops.
Yes. All right, we are at 2:03. So thank you to everyone that has joined. We are halfway through. No, we are actually halfway through +1 of our first OPEA Hackathon. So far, so good. We've had a bunch of interest from different people. We've grown um, our mailing lists, our socials. That's been really good. We've actually got about 10 of the 75 issues have been assigned to people. I'd really love to see a bunch more. I know that people have been ramping up, obviously have their day jobs, which is fine, right? Of course, I guess. But I'd love to see in the last couple of weeks people jump in and let us know if you need help. We're here. I can connect you with the right people. I know a bunch of people have reached out to Malini to get set up with some resources so they can spin up a VM and check things out. So we are first going to have a session and then we're going to have hopefully a good conversation about what's going on, maybe highlight a couple of the different issues and go over, how everything works again, like we did the first time. This time we're also being simulcast onto LinkedIn correctly. So hello, LinkedIn. And we're also going to be on LF AI and Data's YouTube, and that will live on as YouTube does. So to start with, we are going to have a presentation on vector databases from Stefan Webb, who I've just recently met. Awesome person. He is a developer evangelist from Zillis, who I found out recently as well, according to Forrester Wave research report, is a leader in the vector DB space. Not surprising, but still, I was like, oh, good for them. Previous to Zillis, he was an AI researcher both at Meta and Twitter, and fascinatingly majored in philosophy and machine learning at the University of Oxford. We'll have to talk about that later. So I'm going to send it over to you for about 30 minutes. Then we'll have some Q&A at the end. So everybody be thinking about what they want to ask. And take it away, Stefan.
Yeah, thanks so much, Rachel, for the warm welcome. And welcome to all of the attendees today. Thanks for being here. So my name's Stefan. I'm a developer advocate or developer evangelist at Zillis. And so Zillis is the company that is responsible for the open source vector database Milvus, although it's now handed over to the Linux Foundation for AI and Data. So does everyone know what a developer advocate does or is? Maybe get some interaction in the chat section. So let me just very briefly explain. So my role as a developer advocate is to bridge the gap between developers and users of Milvus, so people like yourself. So we do a bunch of things like we do talks, we produce other content. We really love attending meetups and meeting folks like yourself. So we're here to help users get the most out of Milvus and solve all of their technical challenges. Okay, so I've got my details there. So feel free to add me on LinkedIn. You can send me an email. I'm very happy to have a chat. So maybe before we get started, I just want to sort of gauge the level of background. So have you heard of how familiar are you with vector databases? Is this like a totally new concept, or something that you're quite familiar with? Maybe if people wanted to just sort of write a few comments in the chat.
My 2 cents is tell people about it.
Totally new.
And its role like in Gen AI.
Got it. Okay. So yeah, I like to motivate the concept of vector databases with the example of semantic search at web scale. And so I've got a screenshot here from a really cool website or product called perplexity.ai. And if you haven't heard of this, so it's essentially like a web search that is using large language models plus a vector database to index the web and to produce your the responses to your web searches based on what it's indexed. So I've just got like an example here. I've typed in, how does a vector database work? And then it gives this answer. So a vector database works by storing, indexing, and searching data represented as high-dimensional vectors. And then it gives, I think, like a pretty good summary, perhaps like even better than a Wikipedia page. And you can see that to produce, so this output is the output of like a large language model. So think ChatGPT, but it's drawn upon sources from the web, and it gives those sources in the top. You can see them in the top column. For example, it's using one of our blog posts. What are vector databases and how do they work? So I think this is, if you haven't used perplexity.ai or some other semantic search web engine, really encourage it to sort of like see how sort of like different and exciting it is from traditional Google search, for example. So I think this is like one of the killer applications of generative AI. And this is something that depends, or sort of vector databases are a fundamental component. So you wouldn't be able to build this without efficient, effective, scalable vector databases. So very quickly, when I say semantic search, I'm sort of putting that into contrast with lexical search. So a traditional search would be primarily based on keywords, whereas semantic search is based on representations from deep learning models that capture the semantics of text, images, audio, and so on. So, but why is this difficult? Well, I think fundamentally because we haven't up until say like 10 years ago, we haven't had the models to produce those representations. So if we're just sort of working off by keywords, just say we have Apple. Does that mean like the fruit? Does it mean the company? Imagine you searched for rising dough. Just by the keywords alone, it's going to match those keywords, but not related keywords potentially that mean the same thing. So proofing bread means the same thing as rising dough, but would a lexical search be able to necessarily capture that? And then in the third example, the query is change car tire. And so we've got two images there. So one is sort of like how to change a car tire, and the second one is like when. So how can kind of lexical search, how well can it capture the intent of the searcher? So why is semantic search important? Well, I think the main reason is because the vast majority of data is unstructured data, and we need semantic search to search unstructured data that doesn't have like a readily available feature representation. So by unstructured data, we mean everything from documents, images, audio, maybe like conversations online, could be like graphs, like social network graphs, geolocation data, even biotech data like DNA strings, point clouds for molecules. So all of that is unstructured data, and we really need semantic search to make sense of it. So I mentioned that like the challenge with semantic search is we need like a feature representation that can capture some sense of the meaning. So as opposed to like, for example, a bag of words, we need something that captures the meaning of inputs like words, but also has some sense of the relationship between them. And so the solution, of course, is deep learning, and these really powerful models, sort of, I guess, sort of been around for the last 12 years or so. So we take how this works is we take our knowledge base, we put that through a deep neural network, which then turns it into features, which are like sequences of numbers or vectors, which represent those inputs. And then to perform semantic search, we can do like a similarity search in this high dimensional space of vectors. And so if two vectors are close in this vector space, then if our learning's been successful, they should have some sort of semantic similarity, which I'll illustrate in a second. So we sort of like motivated semantic search. We've explained this solution of producing these vectors or embeddings with deep learning. But now there's a new challenge. So how do we actually do this vector search efficiently and scalably? And so some of the challenges are, how do we index and search this space, given that it is potentially like a very high dimensional space? So embeddings may have like 300, 700, even thousands of dimensions. And then how to scale that up. So you typically, at sort of like a, like a practical example, I'd say like you'd have tens to hundreds of millions of these vectors. But in other applications, you could have 10 to 100 billion vectors, or even trillions of these vectors if you're building something at web scale, like semantic search on the web. And the third challenge is, how can we work across different types of what are called modalities, so different types of data? How can we relate the meaning of text to images, or images to audio, and so on? So to meet these challenges, this is where vector databases come in. And so I wanted to introduce to you one in particular, so called Milvus. And it's an open source vector database with really good performance and very scalable. So it's an open source vector database to store, index, manage, and use the massive number of embedding vectors that are generated by your deep neural network model. So Milvus, it's open source. It comes in like a few different deployment options. So if you just want to do something on your local machine, there's a version where you can run it in the Jupyter Notebook. If you want to sort of maybe start up like a server to sort of serve stuff within your company, there's a version that runs in a Docker image and can be used as like a server that you can connect to. But if you want to sort of go to like the larger scale, it also runs on clusters of machines. And in that way, you can literally scale up to hundreds of billions of vectors. And so in terms of like how we meet these challenges, there's very specific algorithms and data structures for searching vector spaces efficiently. And so a vector database software like Milvus, one of the key benefits is it implements those methods and then sort of makes it, I guess, like opaque to the user. So like you don't have to worry about all of the complex techniques going on behind the scenes to do efficient search. So Milvus is open source and widely used within industry, everywhere from IKEA, eBay, Microsoft, Airbnb. A lot of it's sort of like I would say like the most popular or most widely used open source vector database. And I think because of that, it has a large number of integrations with all sorts of generative AI tooling, both open sourced and closed source. So you may have heard of Hugging Face, so integrates with the Hugging Face libraries, but also OpenAI with on the other side with lots of tools to build, I guess like sort of more complicated generative AI pipelines for agents or more advanced retrieval augmented generation systems. So let me just briefly make a case for open source. So why would you want to use open source software like this? And I think I think I can think of a dozen reasons, but the three main ones are flexibility, innovation, and community. So you get the flexibility of the fact that you have the source code, you're not locked into a vendor. You can, if there's any sort of customization, you can do that. We also have like a paid hosting service. So maybe some people don't want to host their own vector database, and then we can provide that as a service. But you have that flexibility. Secondly, innovation. I think the fact that it's open source, anyone can contribute to it, means that the set of features sort of is improved. The set of integrations, the set of features, the pace of that is really much faster than a closed source system. So I think that's why one of the reasons why we're integrated with so many, or like the majority of generative AI tooling. And thirdly is the community. There's a really good community around Milvus, and I'll provide some links later on. We have a very active Discord where you can have a chat to a developer advocate like myself. We're very active on LinkedIn and Twitter. I'll tell you more about that at the end. So I think another important question to ask is, why do we need vector databases? Why not just use like a relational database or a NoSQL database? And the reason is that vector search has unique challenges that mean that it needs these really specialized data structures and algorithms to perform the search. So you could sort of take a relational database, build some vector features into that. But those sort of systems that have like vector search as like an add-on, typically it's not the best way to go about building a system that you really want to scale. So I think to build a system that scales up to hundreds of billions of vectors, you really need to start from the ground up and design your system, especially for vector search. But I would say like they're complementary. So there are some things that you would want to do with a relational database that a vector database is not suited for, and vice versa. Okay, so moving on. So I mentioned before semantic similarity. And so I've got an example here. We've got some sentences and some images. And imagine we have two deep neural networks that can embed those into the vector representation. So I've illustrated these as like points in three-dimensional space. Of course, it will typically have like 300, 700, or thousands of dimensions. It's just like an abstraction. Okay, so we got these three sentences. Let's look at the dog is walked, and at the bottom there's an image of a girl walking a dog. So if our learning has been correct, because those two things are just different ways of representing the same idea, the vector representations should be close in space. And so that's what I meant by saying this is like a representation which gives us, it sort of tells us about the relationship between different items, and as opposed to like a one-hot encoding or like a bag of words that doesn't give that relationship between the items. Or you could look at the lion sleeps, a lion roars. I haven't got the arrows here, but just imagine they're one of these clusters off to the right. So for example, the two green crosses. And because they're both on the same topic as a lion, so those two embeddings are closer to each other relative to the embedding for a dog is walked. Okay, so we've got these, we've got our data, we've got a model to perform the vector embedding. How do we actually do similarity search? So the steps are like so. So we start off with our unstructured data, whether that's image, video, documents, etc. And then we put those through our deep neural network encoder, and that transforms it into these vectors or sequences of numbers that represent the input. And then we can store that in a vector database. So this unstructured data is the data that we want to index and search. So this is something that we do beforehand, before a user comes in with a query. And then in step number 3, a user comes in with a query, and it may be text, but it doesn't have to be. It could be like an image query. It could be like an image plus text. It can really vary depending on the model that you use and what it supports. So we take those, we put that through our deep neural network, which is typically the same as the one that embedded the unstructured data for our database. We then get a vector embedding for our query input, and we can then query the vector database, or we can get it to perform an approximate nearest neighbor search in that high dimensional space to find the closest entries or vectors in that space. And it'll return the results. We could do several things with it from there, depending on the application. You may be interested in the results in and of themselves, or you may want to use them, for example, to provide the context for a large language model prompt, which is known as retrieval augmented generation. You may want to use it in a recommender system. So those would sort of be like your candidates. And as I mentioned earlier, so Milvus has several deployment options, whether you want to just sort of like prototype stuff in a local notebook, whether you want to use it on a single machine, but like serving multiple people, or whether you want to use it on a cluster of machines and scale up to hundreds of billions of vectors. Okay, so I'm just going to skip over this one, but if you're interested, Malini.
Hi, Stefan. I just am curious, in your previous slide, when you have like different kind of media, whether it's text or PDF, one more slide, is that embedder different for video versus image versus documents versus audio? Would also the vector be different? So when I do my similarity search, do I go to different instances of the vector database?
Yeah, sure. So great question. So I guess there's like multiple options, but I think the sort of like the interesting one that has been explored in the last 12, 24 months is to train embedding models that can embed, for example, images and text into the same space. So in general, if you have like a separate image embedder and a separate text embedder, there's going to be no relationship between the embeddings between those two different models. Even if you just train the same model twice, it'll be a totally different space. So there are ways where you can sort of like simultaneously train two embedding models for image and text, for example, where you'll be sort of the learning process will encourage those two spaces to overlap or to agree with each other. And when you do that, you can then store both image and text vectors in the same vector database.
So you can answer across images and video and audio. Okay, got it.
Yep, got it. And you just need to make sure that there is like a model which has already been trained to do that for you. So Hugging Face, a great place to look for like what's out there, or whether you sort of have the resources and bandwidth to train your own model. That's also an option.
From your experience, how good are these multimodal embedders? Or is it cheaper to use single embedders? Or I'm just curious.
Yeah, sure. So they work surprisingly well. And how about I'll run a little demo in a short while. So I'll show you how you can embed both like a combination of an image plus like a search instruction, and then it'll give you back an image. And that's sort of, I think it's quite like an impressive example of what you can do, like when you scale up the training of these models.
Thank you.
Great questions. And do feel free just to if you have a question, just raise your hand in the Zoom, and really encourage that. Okay, so Milvus also has like really good performance. So Milvus is open source, but also our benchmarks are open source. So you can go to that GitHub repo. You can check out like the numbers, but you can also see exactly like how. So yeah, exactly how we've run the benchmarks and tried them yourself. Okay, so let's do a little demo. So I've got here a link to a semantic search that we've built with Milvus. So I'm going to open up here. Is this a good size for everyone? Can you see? Okay, yeah. So this is what's called a multimodal image search. And so what that means is it's operating on multiple modalities. And in this case, it's operating on, so the inputs are an image and an instruction with text. And then the output will be an image that's retrieved from the vector database. So, okay, we've got some examples here. So just imagine our search image is a red car. So we can then type in the text, similar type, but in blue color. And then we'll perform our search in the vector database, and it sort of quite astonishingly finds a similar car, but in blue. So now another example, we've got an image of a toy truck, and then the text is toy of this. So we'll do a search. And because the vector database had those images in it, they'd be indexed beforehand. Plus also the fact that these multimodal embedding models have been successfully trained by the researchers that built them, means that we can turn that combination of image and instruction into like a successful retrieval. Let's try. Okay, so we got the Eiffel Tower text in sunset. And yeah, so I think this is quite like a sort of a amazing like example of what happens when you're able to really scale up deep learning. So this is just like an example of like a semantic search system that you can build with Milvus. And so check out our tutorial here. It's based on a paper by Google called Magic Lens. And we have like a full tutorial to show you like how to actually build this yourself. And it's actually on the face of it, like it might seem like magic, but actually building the system is not too hard at all. So encourage you to check out that tutorial. So I think we're almost coming up to the half an hour. So I'm just going to very briefly, there we go. Very briefly, just sort of show you how you actually use Milvus in practice. And so I'm going to use Milvus Lite, which is the single machine version that if you're just prototyping in a notebook, you'll want to use this one. So the first thing is we need to install this Python library, PyMilvus. And there's also, there's other interfaces for other languages like, JavaScript and Go and Rust, but we'll be doing it in Python. And I've got this optional model here. So what that says is also download the optional feature to sort of give like a default embedding model that we can use. So we don't have to worry about calling in another library like Hugging Face. So we install that library, and then we import the important functions from the SDK. And so this class here, Milvus client, that's how you either connect to a remote database or create a vector database locally on your system. So we create this Milvus client object, and we give it a file name. And so because it's a file name and not a URL, that's how it knows to use Milvus Lite, as opposed to one of the other two distributed versions. Once we've opened our vector database, now we want to create sort of the equivalent of a table and put some rows in it. And so in Milvus, a table is essentially the same thing as what we call a collection. So we'll create this collection, demo collection. We need to specify the dimension of the vectors that we're going to put into it. And so now we need to actually produce some embeddings. So what we'll do is we'll use this default embedding function from PyMilvus. So that's available because we added this optional model when we installed. It's if you're interested, it's this particular one in the comment from you can see it on Hugging Face. And then we've got some strings to embed. So this is our input. This is what we want to embed and store in the vector database. So we've got some sentences about Alan Turing, and then we called the encoding function on those strings to produce the vectors. So that runs the neural network, which outputs these vector embeddings. Then we just sort of create like a little list of dictionaries. Each item will be like a row that we want to put into the vector database. And then it's as simple as just saying, insert that data into that specific collection. And so once we've done that, then we can put together our simple semantic search system. So we may have a question like, who is Alan Turing? So we embed that, so we get the embedding of the question, and then we use this function to search for its nearest neighbors in those previous sentences. And you can see that the top match is born in Maida Vale, London. Turing was raised in southern England. So it seems like a successful retrieval. Well, the second one, Alan Turing was the first person to conduct substantial research in AI. So in the interest of time, I'm just gonna skip over the next two bits, but question from Louis.
Yeah, one quick question. So could you explain why you pick nearest neighbor? Do we have option to choose other algorithm?
Yeah, sure. So hang on, I'm just going to post. So I've posted the collab into the meeting chat, so anyone can log in, check that out. It's based on the getting started doc from the website. So check out our docs. But to answer your question, So yeah, so similarities. Sorry, yeah. So nearest neighbor or approximate nearest neighbor is primarily the main way that you search a vector database. You can also do a search by not nearest neighbor, but neighbors that have some threshold in distance. So you can say return the vectors which are distance 0.1 away from my query. But because these are like points in high dimensional space, it sort of makes sense that nearest neighbor is the like technique that we use.
To add to Stefan's comment, Louis, the way you compute distance can be different. You can use cosine, you can use like root mean square. There are different ways to compute the distance.
So is that can we change it, or it's
Yes, you can change.
Okay.
Yeah.
And not only you can change, you can say, get me k nearest neighbors, like 1 to 10, whatever. And then you can even pass it to another re-ranker type of thing, which might use metadata, like the most recent, if it's like a news article or something else, or another model itself.
So is that are those tunable parameter for the client search, or no?
The K is tunable, the distance computation is tunable. Sorry, Stefan.
Oh no, that's okay. So yeah, and so by default, this will be using like a standard L2 Euclidean distance.
Okay.
The inner product is, I would say, like the most common one, because if you normalize your embeddings, then that's just like a dot product. So that's, I would say, like the most widely used one. But where it comes into play is when you, before we perform a search, we have to build an indexing structure to help us do this search efficiently. So it's sort of like a data structure that we can navigate to work out like which subset of the vector database we should be looking in. And so that will be built with a specific metric in mind. So question from is it Chun Tao?
Yeah. So I would like to, hi Stefan. I would like to follow up Louis' question. So like first, a very simple question: why do you use approximate for the nearest neighbor?
Yeah. So great question. So the answer to that is because it's like an expensive operation once you reach a certain scale. So if you just have like say, I don't know, 100,000 vectors, you can just sort of take your query and compare that to each of the 100,000 and find the top matches and do like an exact nearest neighbor. But once you reach, say, 10 million vectors, that becomes prohibitive. And so that's why at that sort of scale and onward, we need these specialized search methods, but they're only approximate. They're only sort of like approximate search.
I see. So the computation cost is less compared to like actual distance.
Yeah. So your computation cost might scale, say the log of n rather than n in the number of vectors.
Okay, got it. And second is following up Malini's explanation. So we have cosine matrix and we have a Euclidean distance matrix.
Yep.
What would you say is like the like trade-offs of these, or like any difference between these two types of databases?
Yeah, sure. So I think some particular, so there's many different types of indexing methods that you can use to make your search effective. And some of those, just by like the maths, they may tend to work better with L2. I think from a computational perspective, the cosine is sort of advantageous in that it's just an inner product if
Right.
normalized. So yeah, that would be my recommendation. Like use that one, and then I think so it's like a good default.
I see. Okay, yeah, that's all my questions. Yeah, thank you, Stefan.
Okay, any other questions?
Can I ask one more?
You may.
So how do we scale if we have multiple database maybe among different nodes? So how do we scale?
Yeah, sure. So that's sort of like built into the design of the system. So the software will take care of that. You may have to, I mean, yeah, I guess like you sort of like worry about, or you'll have to worry about the details of the hardware, how you set up the cluster. But in terms of like the design of the distributed system to scale up vector indexing and search, that's sort of like one of the main value propositions of Milvus. So Milvus will handle that for you. And then if you don't want to also handle the hardware side, then we have like a commercial hosting service too.
Also, one related question: do we do search on the local data if the data is not in different node, or so
Yeah. So if you're doing the fully distributed system, then I think the sort of abstraction of node may not necessarily sort of correspond to like a single machine. I think, yeah, I mean, it's something that you don't have to worry about because Milvus already has like those details really nicely implemented.
Okay, thank you.
All right.
Rachel.
Any closing thoughts you want to leave us with? Well, one thing I want to say is we are going to make sure that Milvus is fully integrated and usable and all of that good stuff with
Nice.
OPEA.
Mhm.
And we have some open issues, 4 open issues, actually, 2 of which have been assigned and 2 are open. And we'll look at that in a minute, but I'll let you have any closing words you would like.
Yeah. So closing words. So one sort of like thought I have is that this is like really awesome technology. So I encourage you to just get hands-on, try and build something. If you're new to the area, building a simple RAG system is like a rite of passage, if you will. But there's other applications, of course. Maybe your company would benefit from like a recommender system that's based on this technology, or just like a general search on your internal data. So my final thoughts are that this is really cool technology, and get hands-on, use all of these open source tools to experiment and play, and yeah, you'll learn a lot and it'll be lots of fun.
Awesome. Good final thoughts. Thank you again for joining us today. Really appreciate it. Obviously, people had questions, so that's great.
Thank you.
So now we are
Thanks for the
gonna,
invitation.
thank you.
Okay.
We
Bye,
are
Rob.
going to shift gears a bit now. And as I mentioned, talk about the ongoing hackathon, day 16, and talk through, what we've seen so far, what help we still need, and absolutely answer any questions. We have Malini and other OPEA team members here to answer questions. Malini, do you want to start by saying anything? Otherwise, I was going to quickly go through sort of where the issues are and stuff like that.
Just go through.
I'm going to go through it then. All right. I'm going to share, but just chime in wherever. Let's see. Okay. So the first thing I just wanted to show is how we do have Milvus open one. So we have a couple, I don't remember which 2 are taken. So for instance, we absolutely need someone to take on, creating a version with Milvus as the vector DB of many of our examples, but we chose a few of them. And this is actually in conjunction with people from Zillis. So we can definitely, obviously we had Stefan come here, but we can definitely connect you with people to help get this done. So I just wanted to showcase that. And then Just wanted to remind
Just
people.
1 minute, Rachel,
great.
and now that we have Stefan here, Stefan,
You
is there
might
like a
have-
vector database that people can point to that's free as a hosted service for this demo?
He might have dropped off, Melanie, but
Okay,
we can
okay,
get that
sorry.
info.
Thank you.
Okay. That's okay. So we have our open issues here. So you can look under the project, the label OPEA Hack. And I just wanted to go through them. We have a lot of documentation ones. And we have some people from our documentation team here, which I'll let them say hello in a minute. But what else I wanted to show? I feel like these might be later. Hold on, let's see. We've got some cool ones in here where we want to update with if anyone has any experience with Falcon, TII stuff. We've got some Terraform things here we need help with, you can see. Let's see, there were a couple other ones I wanted to point out. Oh, Cloud Formation Stack. We wanted stuff covered there. Validating with some of these LLM frameworks like Haystack, Llama Index, and LangChain. I think those were all the ones I wanted to showcase. But yeah, as you know, if you're following along in Slack, you've noticed that we've had some people take things up, some individuals, some people from different partners, but 2 weeks to go. And we've had a lot of people take us up on using the Intel Developer Cloud so that they can use a VM and all of that good stuff, and have reached out to Melanie, and that's how you do that if you do indeed need a service like that. So the only other thing I wanted to show, let me see, this is always difficult to see. I just wanted to look at the main project again here for anybody that's taken a look. Here is where you can see all of the different examples that we have. I think we have 16, 17 of them. So you can see there. The different components that make up each of those examples can be seen here. Like this is where we want to make sure that let's see, hold on. Vector stores like Milvis is fully filled out and stuff like that. So we'll talk to Stefan and make sure it is. And then we have, oops, one more back. The infrastructure, you can check all of that out, all of that good microservices and Kubernetes goodness. And then evaluation. I know we're looking for help on that as well, as far as like how things are running. So we could use help there. We also have lots of working groups. So I wanted to mention that. What else? And then I just wanted to point back to make sure everyone knew we have our website. And I wanted to show the wiki just because that's where this will live. Well, it's going to live in a few places, but you can see different community events. You can go back and check them out if you want to. Obviously, I have to update that, but we have demos that you can look at. And the only other thing I wanted to show here was you can check out calendar of events. So this showcases working groups, upcoming events, etc. Let's see, what else did I want to show? Anything? I think that is it. So I wanted to, let's see. Well, one of the things I wanted to ask, I'm going to stop sharing for a second here, just so I don't know. Okay. I wanted to ask anyone here that was new to OPEA at the beginning of the hackathon, what their onboarding experience was like and how we can evolve and or improve it. Yeah, so that's an open question to the group, either if you want to let us know vocally or put something in the chat. I think that would be really, really helpful. Nobody. Okay, how about any questions at all about either the logistics of the hackathon or any questions about specific issues or reservations about taking something on?
So Rachel, we got feedback from 2 people on the Slack channel on the documentation, and they were good. One was like, they wanted to do it on their laptop, which was a Mac, and of course we didn't have instructions for that.
Yeah.
And then the other one was like, then they moved to AWS, and what was the size of the instance, and that's something we'll be addressing. Another one we had was this person just wanted to build, and they built it, so they were happy. And of course, they can't just do it on a small machine like an Intel NUC. They need a larger machine because these LLMs are chubby fellows. So
How
we
about,
did get 2 people using it.
That's awesome. So yeah, any feedback like that is really, really important to us. So we can obviously make things better. We have a working group that is met once, so it's very much nascent, that is working on improving the developer experience in all different ways. So that's important.
Yeah, and just to follow on with that too, you know, it'd be great to understand where people are deploying. Because I know, as you brought up, the Intel Tiber Cloud as an option, but I'm curious if people are having trouble finding, you know, really where that deployment target should be, and kind of that, you know, what the kind of typical scenario might be across the board.
That's good. That's good to know. We can put that out in a
It can
survey.
even be a little poll over here. Yeah, good point,
Yeah.
survey.
Oh yeah, I don't know how to do a poll on this, but that would be cool. Okay. Let's see, what else did I want to ask? Oh, how about the VM stuff? How are you finding that, Malini? People are there's been a bunch of people. Has that
Yeah, I
been
think I had like 10 or 12 requests at least, and the people seem to be on. The only person who never, came back to me was somebody who had very slow internet connection, so I have to follow up on him. So it ended up that he would have to send us a screenshot, and we wait and we look and then we respond and stuff.
Okay.
But most people seem to be in and doing fine with their SSH keys.
Okay, that's great. So I
And
one of
then
the
we have coupon codes too for anybody who
Right.
wants it, and they expire at the end of the month. So you can have a whole VM for yourself that you self provision for yourself, even without me in the loop, if you want a coupon code.
Okay, that's good to know. And we should put that out as well in the announcement channel. How about anyone out there impeded in taking on an issue? And if you are, is it time? Is it worry that, it's something that can't be finished by the end of the month? Are there any sort of things like that that people are thinking through? Is there anything that we could do differently? That's the other thing I wanted to know. Oh, and I wanted to show one more thing. Oh, I don't have to show it, but basically just keeping it as simple as possible. Once you do look through the issue, and I'll put that link here. All you need to do is put a comment in there and say /assigned me, and I will do that. I am subscribed to those and more 76 issues. So I check my email a couple times a day to see if there are people that are interested and want to add their name to the issue. All right. All right. Any questions? See, I think I sent that to everyone. Okay, issues. All right. Well, then we will leave it there. Final chance. All right. Well, thank you all for coming. This will be available in a few different places. I think YouTube, LinkedIn, we'll have it on that wiki. And I just wanted to mention on the 31st, we will have another virtual event called Gen AI Nightmares, where we're gonna have like a horror Halloween themed event. And we're gonna be telling stories about, Gen AI gone wrong. If any of you have one, let me know. I can add it to the list to see if we have time. And right now we do have time. So I would love if people have more. Definitely costumes and courage, even if we don't see them. And we will be giving out MVPs, prizes for the people that have coded the most, the people that have done the most documentation. And if we see some really amazing mentorship, which is something that we're going to tackle in 2025 through the OPEA project, which is mentorship in open source and coding and career. And I think that'll be cool because I think everyone generally can be a mentor in some things and a mentee in other things. I know that's true of me. So I want to thank everyone from the OPEA team that was here, and I want to thank everyone in the audience. And speak up on Slack. Let's get that discussion going. All right. I will talk to everyone later. Thanks. Bye.
Bye.